Here's the answer for page 78, the written exercises beginning with number 1. We're given an equation that has two variables, x and y, and the directions say to find three roots of that equation, to find three solutions. Because there are two variables, each one solution will actually have two numbers, a value of x and a value of y. That's why we're going to write our solutions as ordered pairs. The other thing we're told for number 1 is what numbers we're allowed to try for x. The domain is the real numbers, so any whole number or integer or decimal or fraction is a legitimate choice for x. A systematic way to find roots to an equation with two variables is to solve the equation for one of the variables. For this problem, we can get the letter y alone by subtracting 2x from both sides. So this makes y equals 10 minus 2x. Another systematic technique to solve these equations is to create what's called a two-column table, where one of the variables is the name of the first column and the other variable is the name of the second column. This is helpful because it organizes our work for us. Let's choose any real number value of x. 0 is a good choice. To figure out what y is, we're going to use the equation that we created that has y solved in terms of x. So y is equal to 10 minus 2 times 0. 10 minus 2 times 0 is 10. This row of the table has generated our first root of our equation. As an ordered pair, it's 0, 10. When x is 0, the value of y is 10. Now let's make a second row to our table. Choose something else for x. 1 is a pretty easy number to do math with. Let's take our equation and substitute 1 where the letter x is. This equation is giving us a pattern to follow to figure out the answer for y. 10 subtract 2 times 1 makes 8. This has generated the ordered pair 1, 8. When x is 1, the value of y is 8. We have one more to go because the directions were to find three roots. So let's choose another number for x. Again, we're told we can use any real number. We could use 2. We could use negative numbers. We could use fractions, whatever we want. I'm going to choose 2. Follow the pattern to figure out what y is. Substitute in a 2 where the letter x is in our equation that we created. 10 subtract 2 times 2 is 6. So we have determined that the ordered pair 2, 6 is a root of the original equation. We were asked for three roots and we were told to write them as ordered pairs. So here are three ordered pairs. There are many other ordered pairs, but these are the ones that use the values of x that I chose to use in my table. Now number 3, let's follow a similar technique and be systematic. Systematic means you try to solve the problems in the same way every time. Let's solve this for y. So first, subtract 5x from both sides. This makes negative 7y equals 1 minus 5x. Then divide by negative 7. This makes y equals 1 over negative 7 minus 5x over negative 7. We can simplify this a little bit. This is y equals negative 1/7 plus 5/7 x. The reason this is a plus sign is because of this negative divided by negative. We're told that when we try to find roots, that we can use any real number as our substitution values. Let's make a table again because it helped us to organize our work in a nice, neat manner. Choose something for x. Hey, let's choose the number 0 again. It worked well for us last time. So to find y, we use this open sentence pattern that we created. Y equals negative 1/7 plus 5/7 times, and where x is, fill in 0. This makes negative 1/7. So the first row of the table shows us that an ordered pair is 0, negative 1/7. When the value of x is 0, the value of y is negative 1/7. Let's choose another number for x. Again, we're allowed to choose any real number, but if we make wise choices, the arithmetic is easier. Take a look at what you're doing in this pattern. Notice how the number you choose for x is going to get multiplied by 5/7. You're going to multiply by a fraction that has a denominator of 7. So if you choose multiples of 7, it'll make the arithmetic easier. Let's choose x as 7. Y equals negative 1/7 plus 5/7 times 7. And figure out this answer. 5/7 times 7 makes 5 because the 7 in the bottom and that 7 cancel. And then we have negative 1/7 plus 5. That's the mixed number 4 and 6/7. So this is the ordered pair 7, 4 and 6/7. You don't have to choose 7 for x. You can choose any number you want. But by choosing a multiple of 7, you can do a little bit of cross-canceling. Let's choose another multiple of 7 for x, this time 14, and follow our pattern to figure out what y is. Fill in 14, where the letter x is. 14/7 reduces to a 2, and 5 times 2 is 10. So we're going negative 1/7 plus 10. That makes 9 and 6/7. So the ordered pair shown in this last row of the table is 14, 9 and 6/7. Here are 3 roots to the original equation, 3 solutions of that equation. Number 5, we have another equation with 2 variables in it. It doesn't have x and y, it has r and s, but let's use the same technique. Let's solve for one of the variables. Subtract 3r from both sides. We get 4s equals negative 1, subtract 3r. Then divide by 4. We get s equals negative 1 over 4 minus 3r over 4. Let's make a table with 2 columns, but this time the variables are r and s instead of x and y. When we make columns with x and y, we write x first because alphabetically it comes before the y. We'll do the same with r and s. The letter that comes first alphabetically goes in the first column. Let's choose an integer for r. 0 is an integer. S equals negative 1/4 minus 3/4 times 0. I'm following the pattern that was created from this equation here when I solved for s. 3/4 times 0 is 0, so this makes negative 1/4. The ordered pair shown here is 0, negative 1/4. Okay, 2 more rows to go. Let's choose another integer for r. We could use 1, we could use 2 or 3. I'm going to choose 4. S equals negative 1/4 minus 3/4 times 4. Now you can see why I chose 4. So that would cross out, leaving a 1. Negative 1/4 subtract 3 makes negative 3 1/4. The ordered pair is 4, negative 3 1/4. We need another integer. Using another multiple of 4 would be a wise choice. We could use 8 or 12. We could use a negative number such as negative 4. S equals negative 1/4 minus 3/4 times negative 4. The 4's cross cancel, leaving a 1. Negative 3 times -1 makes +3. A -1/4 and a +3 is 2 3/4. So as an ordered pair, this is -4, comma, 2 3/4. Here are 3 roots to the original equation. Number 7, let's use the same systematic approach where you solve for one of the letters. So let's try to get the letter y alone on the left side. First, do the distributive property. We get 7 minus x plus y, and then equals the 2x plus 4. I'm distributing that negative sign to the terms in the parentheses. Now, add x to both sides. 7 plus y equals 3x plus 4. And then subtract the 7. Now the letter y is alone. 3x minus 3, because 4 subtract 7 makes -3. Let's make a 2-column table for x and y. We're told to try integers. 0 is an integer. Let's use that. So y equals 3 times 0 minus 3. I'm following the pattern shown by this equation that I created. This turns out to be -3. So as an ordered pair, 0, comma, -3. Okay, let's choose another integer for x. 1 is an integer. Y equals 3 times 1 minus 3. That makes 0. As an ordered pair, when x is 1, y is 0. Okay, let's choose another integer. We could try more positive integers. We could even use negative integers. I'm going to use 2. Y equals 3 times 2 minus 3. And that turns out to be 3. So as an ordered pair, a root is 2, 3. Here are 3 roots to the original equation. Number 13, same directions. We're going to find 3 roots, but this time we have an inequality. Let's use our same systematic approach and solve for the letter y. So first, subtract 2x from both sides. We get -y is greater than or equal to 4 minus 2x. Now divide by -1. Flip the arrow because we divided by a negative. This makes -4 plus 2x. Let's make an xy table. And choose a number for x. How about 0? Now let's follow our pattern. Y is less than or equal to -4 plus 2 times 0. This makes y is less than or equal to -4. Think about what we have just figured out. When the value of x is 0, the value of y turns out to be anything that's less than or equal to -4. We can find lots of ordered pairs just from this row of the table. For example, one of them is when x is 0, y could be equal to -4. Another possibility is when x is 0, y could be equal to -5. Remember, y is anything that is less than or equal to -4. -5 is less than -4. Here's another possibility. When x is 0, y could be -6. Here are 3 roots to the original equation. And every one of these uses the same value for x. We didn't even try to use more rows to our table and pick different numbers for x. Number 15, let's use our same systematic approach and solve this for the letter t. So first the distributive property, 2 times k, and then 2 times t. Next, let's combine like terms. So 2k and then positive 2t minus 3t combines to a negative 1t. Next, let's subtract t from both sides. We get 2k minus 2t is less than negative k. I get negative 2t here because I have a minus t and I'm subtracting a t. Next up, subtract 2k from both sides. We get negative 2t is less than negative 3k. Then divide by negative 2. We get t is greater than negative 3k over negative 2. This is the same thing as saying t is greater than 3 over 2k, because negative divided by negative makes positive 3 over 2. Now let's make our two-column table. K first, then t, because of alphabetical order. We're told to try integers. 0 is an integer. Let's use that. So t is greater than 3/2 times 0. This is equivalent to saying t is greater than 0, because 3/2 times 0 is just 0. Because this is an inequality, we can come up with 3 roots just from this row of the table. When k is 0, one possible answer for t would be any number greater than 0, such as 1. Let's try another one. When k is 0, what's another possible answer for t? Remember, t is anything greater than 0. Well, it could be 2. And another possibility, t could be 3. Here are 3 roots to the original equation. Number 17, the absolute value of x plus the absolute value of y is equal to 2. We can apply our systematic approach on this one if you want, or we can leave it in this form and use guess and check to get answers for x and y. I'm going to apply the systematic approach. So subtract the absolute value of x from both sides. That gets this term alone. And over here we have 2 minus the absolute value of x. What I'm not going to do is do a step of work that gets rid of the absolute value bars. I'm going to leave it in this format and try to figure out answers for x and y from here. Let's make a table. We're told to consider integers. Well, one integer is the number 0. So we have the absolute value of y is equal to 2 minus the absolute value of 0. This is equivalent to having the absolute value of y is equal to 2. There are actually 2 numbers that work for y. The absolute value of negative 2 makes 2, but the absolute value of positive 2 also makes 2. So just from this one row of the table, we've actually found 2 ordered pairs. When x is 0, y could be negative 2. But when x is 0, y could also be positive 2. Now this isn't enough because we're supposed to find 3 roots, so let's make another row to the table and try another integer for x. How about using 1? Now let's follow our pattern. The absolute value of y equals 2 minus the absolute value and fill in 1. This is equivalent to the absolute value of y equals, figure this out right here, 2 minus 1 makes 1. This statement actually tells us 2 different answers for y. Y could be negative 1 or y could be positive 1. So the second row of the table has really generated 2 ordered pairs. When x is 1, y could be negative 1. Or when x is 1, y could be positive 1. We have found one more root than what we were asked to find. Next, number 21 changes the direction. No longer are we trying to figure out roots. Instead it says, find all possible values of x and y. We're given ordered pairs. Notice the comma in here separating the first and second coordinates. And the two ordered pairs we're given are equal. That means their first coordinates must be equal and their second coordinates must be equal. Let's take that fact into account and make some equations. This must be equal to this. We can write that down. The other thing we know has to be true is that this one has to be equal to this one. So let's write that down. We just wrote down some equations and we can solve them. So let's focus on the first equation and solve it. Subtract x from both sides. We get 4 equals x plus 7. Now subtract 7. We get negative 3 is equal to x. With a symmetric property, that's the same as x equals negative 3. Now focus on this equation. Let's subtract 2y from both sides. We get negative 3 equals y plus 8. Then subtract 8. We get negative 11 equals y. We found the answer for x, and we found the answer for y. Now page 80, question 1. We're given a paragraph describing a word problem situation. We're told that we have two integers, and they average to 76. That means if you add them together and divide by 2, the answer is 76. For question A, we're asked to find two positive integers that would work. Let's call the first integer x and the second integer y. The very first sentence says, when you average them, you get 76. So when you add them together and divide by 2, you get 76. Let's rearrange this a little bit by multiplying both sides by 2. We get x plus y equals 152. Now we can find answers that work for x and y. One possibility is x could be 1 and y could be 151. No doubt you see that there's many other possibilities for x and y. Okay, part B. We're asked to do the same problem, but to figure out a positive integer and a negative integer that works. So what is a positive number and a negative number that add up to 152? One possibility is 153 and negative 1. Those two numbers add up to 152. Okay, number 3. Jack is 8 years more than twice as old as Fran. Give two possibilities for their ages. Let's use the letter J to be Jack's age and F to be Fran's age. And read the first sentence again. Jack is, so J equals 8 more than twice Fran. So 2 times Fran plus 8. Here's how you show the first sentence in symbols. It says to give two possibilities for their ages. Well, let's fill in numbers for F and figure out the corresponding values for J. What if Fran is 1 year old? How old's Jack? 2 times 1 plus 8 makes 10. So one possibility is Jack could be 10 and Fran could be only 1 year old. We're asked to give another possibility. Well, let's try a different number for Fran. What if Fran is 2 years old? Then how old's Jack? 2 times 2 plus 8. That's 12. So Jack could be 12 years old if Fran was 2 years old. There are lots more possibilities that you could come up with. Next, number 5. Together, Jack and Jill carried at most 11 full pails of water. Find two possibilities for the number of pails that they carried. Let's use capital J for how many pails Jack carries, and let's use a lowercase j for how many pails that Jill carries. We're told that together they carry at most 11. So together means you add them together. And if it makes at most 11, that means less than or equal to 11. At most 11 means you're not more than 11. Let's use substitution to find answers that work. What if capital J was 1? What's a possible answer for lowercase j? 1 plus what makes an answer less than or equal to 11? Well, one possibility is 10. So Jack might carry 1 pail and Jill might carry 10 pails. But there are more solutions even when you use 1 for capital J. Another possibility for Jill is she might carry 9 because 1 plus 9 is also less than or equal to 11. So another answer is Jack might carry 1 pail and Jill might carry 9 pails. There are many more possible answers. Next, number 9. A rectangle has a perimeter of 30 inches. Give all integer possibilities for the length and the width. So the clue we're going on is when it says that the perimeter is equal to 30 inches. If you add up around the outside, it must add up to 30. I drew a picture of a rectangle to help me focus on what's going on. Let's try numbers for the length and the width. If the length was 1, then what must the width be so that it adds up to 30? This has to be 14, and this has to be 14, because 14 plus 1 plus 14 plus 1 makes 30 inches. So one possible answer is that the length is 1 inch and the width is 14 inches. Let's find another possible answer. Instead of using 1 for the length, let's use 2. Then what would the width be? This would be 13 and 13, because 13 plus 2 plus 13 plus 2 makes 30. So the length could be 2 inches if the width was 13 inches. Let's find another possible answer. What if the length was 3? Then what could the width be? 3 and 3 is already 6. 30 subtract 6 is 24, and splitting that into 2 sides would be 12 and 12. 12 plus 3 plus 12 plus 3 adds up to 30. So another possibility is the length is 3 inches if the width was 12 inches. We're going to keep following this pattern until we've done all the possibilities. We can make this easier if we try to look for a pattern in our answers. Look what's happening to my values for length. And look what's happening to the corresponding values for width. So without adding to my picture, I think another possibility is 4 inches if the width was 11 inches. And another possibility is the length could be 5 inches if the width was 10 inches. Another possibility is the length could be 6 inches if the width was 9 inches. Another possibility, if the length is 7 inches, then the width must be 8 inches. Now look what happens if I do one more of these. Increase that to 8 and shrink this to 7. What do you notice? This rectangle is really the same shape rectangle as this previous one. The pattern is going to start to repeat itself. So I don't want to have that last answer on there. That would be duplicating one of the answers I already figured out. So here are all the possible dimensions of the rectangle.